Okay, we are going to talk about sample spaces today. It's 711, so it should be the first thing in your packet. And you just have a set of notes for today. But we're talking about sample spaces. We're getting into the unit on probability here. A lot of people tend to like this one, but there is a lot of information in this unit. I'll just give you that heads up. So make sure you're taking good notes, highlighting stuff if you need to, and going from there and watching these videos. Okay, so there are examples where being able to assess the likelihood that some event occurs could be useful in making a decision. So think about that. What we're going to get into here is how you assess the likelihood that an event occurs and use that in making a decision. Okay, there's lots of different things out there. There's the stock market. There's whether I bet on a team to win something. There's a lot of different examples out there where you want to assess the likelihood of something happening to make a decision. Okay, here's 3 examples of this. You do not have these in your notes, just kind of hang with me here in the first part of the video. Okay, but number 1 is you haven't studied for tomorrow's test. Okay, a local meteorologist says that there's a 70% chance that by the morning there will be a foot or more of snow on the ground. Do you stay up late to study or go to bed? Okay, so think about that and how that goes. You have to assess the likelihood. Letter B is suppose instead a local meteorologist reports that he expects only a dusting of snow. However, he warns that there is one weather model that projects over a foot of snow. He thinks the likelihood of that happening is only around 10%. So in this example, do you stay up late or go to bed? Okay, so think about what you would do, but do you use those? Do you put those into consideration? Okay, number 2, you buy a new cell phone. If your new phone is damaged or stolen within the next 2 years, a replacement phone would be really expensive. After 2 years, you would qualify for a phone upgrade at a reduced price. So, letter A, would you assess the chances of your new phone being damaged or stolen in the next 2 years as low, moderate, or high? And then based on that, letter B, should you buy an insurance plan for your new phone? Okay, so based on some information, based on where you feel like your chances of damaged or stolen phone is, do you buy the insurance plan? Okay, and how do those go together? Situation number 3, the Connecticut Lottery's Mega Millions jackpot is reaching a record payout. Should you encourage your parents, we know you can't bet, to rush out to play the Mega Millions in hopes of winning the super big jackpot? Okay, by the way, the chances of winning the jackpot are 1 in 258 million, 259 million approximately. Okay, so those are 3 situations where you would have to assess the likelihood of the event occurring and then make a decision. Okay, so you could think through and you could provide your own examples. There's lots of different examples out there. You can talk about gambling, so roulette. You can talk about basketball. You can, some people decide either do I follow them or do I not? Okay. You can talk about whether there's a tornado is going to hit your house, the likelihood of that. Shark attacks, whether you're going to get attacked by a shark if you go out in the ocean. You can talk about all kinds of things. Are you going to get a flu? Okay, we've got all kinds of things that are going on right now that you can talk about with this. Okay, so these examples provide insight into 3 concepts. Okay, they're going to cover the next few days in class here or at home, however you want to say it. And those words are sample space, events, and probability. So sample space is the main idea for today. Okay, we'll get into the events toward the end of today, and we're talking about probability through all of this. So we're kind of discussing through a lot of different topics here. So the following are important terms in regards to probability. So if you have your notes, I have you copying down these first 2 terms at the top of your notes there. You have a random process. And if you're deciding to highlight stuff, I would just highlight these 2 terms because this is kind of your main concept for what you have today. So we have a random process here. Ooh, technical difficulty there. There we go. Which is a process that can result in a variety of outcomes, but you don't know which outcome will occur in advance. Okay, so that's essentially what all of these different things we have. And then a sample set, and this is the big idea for today, is the set of all possible outcomes of a random process. We're going to get to those ideas when we get to the examples here in a little bit. The set of all possible outcomes of that random process. We often designate the sample space as S and describe it using set notation. So we would put a capital S equals, and then we're going to do these little curly brackets, and we list whatever the possible outcomes are. Okay, so that's what you're going to be doing here in just a bit, but that's how you list what's going on. Okay, so what's the possible sample space of example 1? So example 1 was the snowfall idea. Okay, so possible sample spaces, and it depends on how you look at the situation. Okay, you could have a sample space that talks about if the snowfall is above 12 inches or if the snowfall is below 12 inches. So just two options. You could have a sample space that is the snowfall sufficient to cancel school or is the snowfall not sufficient to cancel school? So two options, but it brings school into the mix. Okay. And then the third could be the amount of snow in inches that have accumulated by morning. So this sample space is an interval from 0 to 36, or whatever you decide in this case, but from 0 to 36, you could have the numbers from 0 to 36. Okay, so lots of different options there. Are there other possible sample spaces? Yes. Okay, so that's just an idea of it. Sample spaces may involve the different things. Okay, it could be a finite number of outcomes. Okay, so that's your snowfall example and your cell phones example. There's only so many possible outcomes there, or an infinite number of outcomes. That can be like your snowfall example where you've got your snowfall being 0 to 36 inches because it could be 0.1 inches or anything like that. So that could be an infinite number of outcomes. Okay, you may care about some sample spaces more than others. Okay, for instance, and what I just did here, I'm going to go back to that. Sample space 2, most of you would probably care about this more than the rest. You don't care if there's 12 inches of snow or not. You care if school's canceled. Okay, and those kind of different things that are there. Random process, there is a second random process involved in some of the sample spaces. In this case, it's whether or not that you prepare for the test. Okay, so tree diagrams help us to describe these. So let's go ahead and look at a tree diagram here. Okay, and this is the idea. So there's a random process. School is either canceled or it's not canceled. Okay, based on the snowfall, again, we could get into that and that could be more, but it's either canceled or it's not canceled. Okay, if school is canceled, the second random process that's happening here is you decided to be prepared or not prepared for the test. Okay, so you studied or you didn't study for the test. If it wasn't canceled, you also had those two options as a possibility. So there's really 4 different outcomes in this sample space. Okay, and they are listed right here so that you can see those different outcomes that are happening there. It does not matter which of these two ideas that you started with. Okay, I could have done prepared and not prepared here, and then done canceled, not canceled, canceled, not canceled. Okay, it comes out to the exact same outcomes, maybe just in a slightly different order. Okay, but there are 2 random processes here, and that's what we use our tree diagrams for. Okay, so I'm going to have you pause the video on the following page and complete question number 1 through 4 in your notes, and then we'll come back together to go over those. So use this table for number 4. So go ahead and pause the video on this, complete question number 1 through 4 using this table on number 4, and then turn the video back on. Okay, I'm going to go ahead and go on with that. You should have completed these. So if we look at these, okay, it said to use set notation to specify the sample space for each situation described in questions 1 through 3. Okay, so that's what we went ahead and did here. A roll of a die, okay, once, or sorry, you roll a die once and record the number of dots on the side that lands face up. Okay, and what do you get? So remember, this sample space is a set of all possible outcomes of a random process. So the random process here is you roll the die. Okay, the all possible outcomes here are everything that it could have been. So it could have been a 1, a 2, a 3, a 4, a 5, or a 6. Notice it's a capital S equals, it's got the curly brackets, it's got commas between all of the possible outcomes. Okay, letter B, roll 2 dice and record the sum of the dots. Okay, the sum. So in this case, we're talking about the sum here. So your random process is you rolling 2 dice. Okay, and then you have your outcomes. Okay, when you roll 2 dice, you cannot get a 1. If you see here, I messed that up in the first place, but the lowest sum that you can get is a 2, and the highest sum, with both of them being 6, is a 12. And you can get anywhere in between each one of those. Now, some of you may be thinking to yourself, well, there's different ways I can get a 7. Do I need to include that? In this case, no, we will talk about that when we get to probability. Okay, this is simply the sample space. Okay. Number 2, record the hair color of the next person who enters the room. So you could imagine somebody walking into the room and you don't know. Okay. Your sample space in this case can be a lot of different things. I just made a sample space of blonde, brunette, or black. You could add all kinds of different hair colors into this, but get the idea of what possibly could happen. So you're looking at the hair color. The random event is somebody's walking into the room with a hair color, and then what is their outcome that comes of that. Number 3, a basketball player shoots a free throw. Okay, your sample space can really be kind of 2 things. You can either do it as a make or a miss. That would cover each one of them. Okay, so the random process, they shoot a free throw, and the outcome is that they either make it or they miss it. The other thing that you can possibly do is, in this case, is you can do it by points. They either score 0 points if they missed, or they score 1 point if they made it. Okay, so those are kind of the 2 different options there. but shoots a free throw, so it's not 2 points here. You would have a second free throw that has the same sample space there. Okay. Number 4, then, if you read through this, suppose you convince one of your parents to play Mega Millions in hopes of winning the jackpot. If your focus is only on the jackpot, the sample space is S equals, and then you either have parent wins or parent does not win. However, there are other prizes your parents might win, even if they do not win the jackpot. So expand the sample space to include all possible amounts that they could win. Okay, assume your parents do not pay the extra dollar for the mega multiplier, so see the board for the payouts. So if you looked at the board, okay, you should have in your sample space is they could have won the jackpot. They could also win $1 million. They could win $10,000. They could win $500. They can win $200. They can win $10. We don't need to add $10 in there again because it's already there. Okay, so we just leave it. They can win $4. They can win $2, or they could not win. So you have to add the $0 to your list. So that's where my sample space of this came from. Again, you don't need to add the $10 twice. It happens once. The probability of this is going to affect the two of them. Okay. And then don't forget your 0 like I did in here. Okay. So that's question 1 through 4. Okay. Now flip your notes over and complete the tree diagrams in number 5 and 6. Okay. Go ahead and pause the video right here. Okay, I'm going to go ahead and go on and go from here. Hopefully you paused. So you got these done. If you look at number 5, it says, suppose a student wants to buy a new cell phone. Before completing the purchase, the student is asked whether or not he or she wants to purchase insurance in case the phone is damaged or stolen within 2 years. Okay, replacing a damaged, lost, or stolen phone within 2 years is really expensive. So the situation involves 2 random processes. Okay, the student might or might not buy insurance. Okay, we don't know until the purchase is completed. So the random process is they're buying a cell phone. Okay. What happens next? The next random process is do they buy insurance or don't they? Okay. So that's what I went with first. Okay. Then the second bullet point, the phone might or might not be damaged or stolen within 2 years of purchase. So we won't know the outcome until the 2 years are up. So if you buy insurance, there's a chance that your phone was damaged and there's a chance it's not damaged. If you don't buy insurance, there's a chance that it's damaged and there's a chance that it's not damaged. Okay, so draw a tree diagram showing all possible outcomes. Again, if you chose to do damaged and not damaged here, and then insurance and not insurance here, that's fine. Okay, but that's the general idea. Then express the sample space using set notation. So make sure that you read this part right here. Our set notation is this, the S equal to curly brackets, and then notice, and I kind of abbreviated, you're more than welcome to do this too, but insurance and damage, insurance and not damaged, and so on and so forth from there. There are 4 things in our sample space here. Okay, and that's what our tree diagram shows, is because there are 4 levels at the end of this tree diagram. There's 4 things in your sample space. Okay. Letter C then goes on to say your mathematics teacher decides to give a pop quiz with 3 multiple choice questions. Don't worry, that's not coming up. And for each question, a student's answer is either correct or incorrect. So C or I, draw a tree diagram to help identify the sample space, the set of all possible outcomes for this quiz. Okay. So the way that this is working is that you have a first question. So this 1C and 1I is the first question is correct or the first question is incorrect. Based on whether you got the first question correct, you either got the second question correct or the second question incorrect. Or if you got the first question incorrect, the second question correct, or the second question incorrect. And then again, off of that, the third question is correct or incorrect, depending on which pathway that you are on. Okay, which makes this the tree diagram and these the final outcome results. So you could have gotten a CCC, a CCI, a CIC. You can keep going through and seeing where I got each of these from. And then I went ahead and listed that in set notation, okay, to give you that whole idea. Okay, so those are question 5 and 6. Okay, you don't have this on your paper, but so I made it up here kind of as a class. It then says number 7, each year, the study Monitoring the Future, Continuing Study of American Youth, surveys students on a wide range of topics. 2 of the questions were, what is your gender, male or female? And yes, I know that that's not necessarily inclusive of everybody, but we're just going to go with that to simplify this for now. And then during an average week, how much do you usually drive a car, truck, or motorcycle? And then the options were given to you as none, 1 to 10 miles, 11 to 50, 51 to 100, or more than 100 miles. Okay, so explain why each student's response to each of these survey questions can be viewed as a random process. Okay, and essentially this idea here, if we go back to the definition of what a random process is, okay, is a process that can result in a variety of outcomes, but you don't know which outcome will occur in advance, is that students could answer anything, okay? So students could have a variety of answers. And in asking somebody and asking a random student, you don't know the result, okay? You don't know the result right now. Okay. In questions 5 and 6, you used a tree diagram to identify the sample space of two random processes. In this case, a table provides another useful way to specify all possible outcomes of two random processes. This table gives the results from the 2012 survey given to 12th grade students. What is the sample space for this situation? So this is where it gets interesting. And tree diagrams can definitely help, but this also gives you something. So what some people will say the sample spaces in this case is none, 1 to 10, 11 to 50, and so on. But that's not actually true, okay? In this case, the sample space comes from what would happen with the tree diagram. You have two random processes happening. There's either female or not, or male, okay? And there's a amount of driving that they're doing. So these are all of your outcomes, okay? So your sample space in this case would be inclusive of everything that's in here. If you want to look at it in form of a chart, you can look at it right there and see those different outcomes. But there's two choices and there's 5, and 2 times 5 is 10. So there's 10 things in the sample space there. Okay. So the last two things that you have on the bottom of your notes, you have two more boxes. You can fill in these definitions. And again, I would highlight them. You have an event. Okay. It is any subset of a sample space or any collection of outcomes are the two things that I wrote down there. Okay, it could be an empty set or it could be the entire sample space. Okay, so realize that you can have a 0% or 100%. You can have all of the outcomes or none of the outcomes. Okay, thinking of that is if I asked you if you roll a die and you get what's the chance that you get a 0? There's nothing in that set. And then if you roll a die and what's the chance that you get a number? Okay, your 1, 2, 3, 4, 5, and 6 are all in that set. So that's the entire sample space. Your notation to take note about, an event is often described by a capital letter near the beginning of the alphabet, such as event A or event B. The sample space, which is also an event, is generally designated by S. Okay, so an example of an event from situation 1 or the snowfall, okay, of an event, okay, could be that that school was canceled. Okay, that would be one event in this case. I could call that event A, and I could talk about all kinds of different things about that event, but that could be an event. It could be more descriptive, okay, that school's canceled and you didn't study for your test, okay? There's a lot of different things that could happen there, and we can go from there. Okay, so that is it for today. Good luck as you're going through, but that's all you have for today. No more homework. Just check back again tomorrow.